My name is Dionysios Raftopoulos, and first of all, I would like to thank the organizers for the opportunity given to me to present this work. The choice of geometrical space. After the fundamental distinction between perceptible space and geometrical space, given by my late professor at the National Technical University of Athens, Panagiotis Ladopoulos, and since all the logically consistent geometries are equally valid, we select the projective space as the geometrical space of choice to formulate a natural theory named the theory of the harmonicity of the field of light. The projective geometry was established in the beginning of the 19th century, mostly by the French mechanical engineer and mathematician Jean-Victor Poncelet. Although Poncelet and his predecessors, Pappus of Alexandria, Johannes Kepler, Gerard Desargues, applied the synthetic method, today projective geometry is mostly developed by following the analytical one. In this work, however, we shall adhere to the synthetic geometric spirit. Projective space is established with 8 axioms and each geometry with 9. The axioms of projective geometry. A. Positional axioms. 1. 2 points define a straight line on which they lie. 2. 3 points not on the same straight line define a plane on which they lie. 3. A point and a straight line not passing through it define a plane on which they lie. 4. 2 planes define a straight line on which lies on them. 5. 3 planes not intersecting at the same straight line define a point which lies on them. And 6. A plane and a straight line not lying on it define a point which lies on them. Before we proceed to the second group of axioms, we have to define the notion of the first-degree geometric formation. That is, the formation whose elements in analytic geometry are defined by a single parameter. For example, the straight line point series is one of them. B. The axioms of order and of the projective character of the direction of movement. 7. If an element O is defined on a first-degree geometric formation, the remaining of its elements can be ordered in such a way so that element O precedes all the other elements. In this order, there is always an element preceding every other element, and between two elements A and B of the formation, if A precedes B, there is always an element that comes after A and before B. 8. In a first-degree geometric formation, there are 2 specific directions of movement opposite each other. If a first-degree formation results from another via a finite number of projections and sections, a specific direction of movement on the first corresponds to a specific direction of movement on the second. C. The Dedekind's axiom of continuity. 9. If AB is a first-degree geometric formation segment on which a direction of movement has been defined, and if this segment is divided into 2 parts so that A. Every element of the segment AB belongs to one of the 2 parts. B. Element A belongs to the first part and B to the second. And C. A random element of the first part precedes a random element of the second. Then there is an element C of the segment AB which may belong to one of the parts, so that every element of AB preceding C belongs to the first part, and every element after C belongs to the second part. Some remarks on the axioms of projective geometry. 1. The axioms of projective geometry introduce automatically to the projective space also its elements at infinity, which are considered totally equivalent to those not at infinity and consequently undistinguishable. As a result of this introduction and equivalence, the 5th Euclidean postulate, parallel straight lines do not intersect, has absolutely no meaning in projective space. 2. The 7th axiom of order closes the straight line. The projective straight line is a closed line via its point at infinity, as opposed to the Euclidean, which is an open one. It follows that the projective plane is also a closed surface via its straight line at infinity, ideal line. 3. Projective space was established with the first 8 axioms. Dedekind's continuity axiom does not contribute to the establishment of projective space. It was introduced, however, to projective geometry by the Italian mathematician Federico Enriquez to offer projective geometry autonomy. Dedekind's continuity axiom, as formulated, constitutes the geometrical expression of the continuity principle of real numbers in analysis. The principle of duality in projective geometrical space. I don't know how to go, but all right. If we classify the positional axioms in 2 groups of 3, the first group comprises the first 3 and the second, the last 3, then by comparing the axioms of the 2 groups, first to the first, etc., we observe that the last 3 result from the first 3, respectively 1 to 1, if, in the wording of each axiom, we replace the word point with the word plane, and vice versa, and keep the word straight line unchanged. Certain changes in the syntax would of course be required. It seems therefore that the concept of an infinitesimally small point is equivalent to the concept of an infinitely extended plane, that is to say, a valid statement containing the concepts of points and planes retains its validity, it is invariant, if the 2 concepts swap their roles. This property, introduced automatically in geometrical space by the formulation of the 6 positional axioms, is called principle of duality in geometrical projective space. Taking a step further, the duality principle holds its validity also at the planar level, where now the point and straight line interchange their roles. Furthermore, the duality principle is also valid for any central beam. Central beam is the set of all the straight lines and planes of space passing through a common point, where the concepts now interchanging roles are straight line and plane. The theory of the harmonicity of the field of light. The foundation of this theory is briefly presented below. 1. The philosophy of the theory. The science of physics, contrary to mathematical science, is basically empirical, practiced by human beings who, being of a material nature, are restricted by their locality. We adhere to the philosophical thought of Weizsäcker and Heisenberg, as it is presented by the latter in his well-known book Physics and Philosophy, and can be summarized in the following statement by the former. Nature is earlier than man, but man is earlier than the natural science. We therefore believe that every natural science ought definitely not to ignore the existence of the observer, who observes and measures the events. Of course, the observer concept is rather elastic and able to refer even to the instrument through which the registration and measurement of events takes place. 2. The first fundamental hypothesis of the theory. The second hypothesis of the special relativity theory refers to the independence of the speed of light from the speed of its source. We shall extend it to cover all interactions of matter, but refer it to the geometrical space only. Thus, our first hypothesis is as follows. Matter interactions occur in the geometrical space at a speed that is essentially constant and independent of the relative speed of interactive elements of matter. More specifically, matter interactions conducted through light occur in geometrical space at a speed essentially constant in magnitude, independent of the relative speed of interactive elements of matter, and equal to the speed of light which I measure in my perceptible space at the place where I am located. I note that when I write the speed of light which I measure in my perceptible space at the place where I am located, I mean the measurement performed via the method described by Einstein in his original paper, using one local clock to avoid the problems used by the two clocks. The concept of the linear array of synchronized clocks. Last, we adopt the definition of synchronization of two distant clocks that Einstein gave in his original paper, and we consider that any logical being performing physical experiments would use synchronized clocks in the various positions of his frame of reference. It is via the readings of those clocks, and only those, that two events can be characterized as synchronous in experimental physics. Specifically, when rectilinear motion is observed and measured, said synchronized clocks would need to be arranged along the length of the path of the object in motion. Thus, the concept of the linear array of synchronized clocks is created, via which the notion of speed is determined in classical mechanics, a notion that is valid in all of natural science. Kinematics of the material point moving with subglobular speed, v less than c, measured by Lask. According to our first fundamental hypothesis, and since the speed of light is finite, a localized real observer does not see nor measure the present position of a linear moving material point, but a previous one, which we call conjugate position. This previous position has been called the retarded position by Richard Feynman. Thus, in reality, the objects of study by real observers and not by omnipresent spirits are not the moving bodies' position themselves, but rather their conjugates. This conclusion, evocative of the shadows in the cave in Plato's allegory, carries critical implications for modern physics. Let a material point moving with a constant speed v measured by Lask on a straight line E furnished with Lask, and let a real observer furnished with a local clock which is synchronized with the Lask clocks. The observer being paused at the random position O outside the straight line E is studying the kinematics of the material point, figure 1. Let the material point now be at position A. However, in the observer's perceptible space, it is not located at A, but rather at its conjugate position A prime. Thus we have A prime A over A prime O equals V over C. If the position A, the direction of movement, and the speed of the material point measured by Lask are given, we are asked to locate the conjugate position A prime. From the well-known bisector theorem, we get equation 2, through which we find points M and H. With the segment MH as diameter, we draw the Apollonian circumference, which crosses line E at points A prime and A2 prime, which are the conjugate positions for the two directions of movement in the Euclidean space. We observe that the two conjugate positions A prime and A2 prime of position A for the same speed v and for the two opposite directions of movement are not generally symmetrical with regard to position A. Here we have discovered harmony. This is because the 4 points H, M, A, O constitute a harmonic tetrahedron. We observe that the double ratio of or cross ratio with signs be given by the red equation equals -1, which constitutes the necessary and sufficient condition for a harmonic tetrahedron. This property of harmonicity is fundamental in nature and is a direct result of the stability of the speed of light, that is, its independence from the speed of its source. Kinematics of the material point moving with superluminal speed measured by Lask. We have shown with a previous paper that the relationship V less than C is not a conclusion of the Lorentz transformation, but rather a hidden precondition of its analytical production. In other words, the Lorentz transformation can only be valid for V less than C. Consequently, a definite rigid law of physics forbidding matter to travel with superluminal speed measured by the Lask in vacuum does not exist. We examine figure 2, the case where the material point moves away from the foot of the perpendicular V and observer O with speed V greater than C, it is now located at position A. We find its conjugate positions A prime and A2 prime via the Apollonian. All the above mean that the signal, image, transmitted by the material point when it was located at A2 prime reaches the observer O at the time set point has already reached A. Moreover, the signal, image, transmitted from A prime reaches the observer O also by the time the moving point has already reached A. In other words, the images from A2 prime and A prime both reach the observer O simultaneously, and he sees the material point to be at two places. Superposition of states, which is none other than superposition of subgroups. Here, the duality in physics, matter-wave, is born. Matter, traveling ultra-fast, demonstrates wave-like behavior. From the projective space to the duality in physics. This phenomenon is not apparent for subnumeral V less than C speeds of matter. This is exactly where the introduction of projective geometrical space is necessary. In other words, while in the Euclidean geometrical space, to each direction of movement corresponds only one conjugate position, in the projective geometrical space, both conjugate positions are accepted because the projective straight line is a closed line via its point at infinity. If we now consider that both conjugate positions, as well as the speed of the moving material point as given, then the geometrical locus of the observing positions O on the plane is a conic section. For example, when V is less than C, it is an ellipse, figure 3, with eccentricity epsilon equals V over C, and its minor secondary semi-axis beta equals its major primary semi-axis alpha, contracted by the Lorentz contraction formula. We observe that in both figure 1 and figure 3, line OA connecting the observer O and the moving material point A is the bisector of the angle formed by the two conjugate positions A prime and A2 prime and the observer O, angle A prime O A2 prime. This observation is of cardinal importance when it comes to connecting the principle of duality with the inverse square law in physics. Why? The file. Draw. I have the next maybe oh no. The draws no. So, I accept your imagination. So, Domenico Bassani for his help. These were choices the projective space, excuse me, as its geometrical space of its natural description. One fundamental feature of projective space is the principle of duality. In the following analysis, we will use the principle of duality. This is, I spoke about last Monday about us.
Which kind of duality are you talking about?
The projective duality, in the projective space. The duality in the projective. So, in this following analysis, we will use the principle of duality in the projective plane, where the concept of point interchanges its role with the concept of straight line. So, let's go then at the place where I stopped. All right, here. So, from the projective principle of duality to the inverse world law. It is well known that the inverse world law in both gravitational and electric fields is empirical, resulting from the observation and experiment. In other words, this law does not stem from first principles. We shall demonstrate that there is machinery behind this law, and that is none other than the principle of duality in projective geometrical space. That is to say, we shall produce theoretically this law. Thus, perhaps, Galileo's position, who proclaimed that the book of nature is written in the language of geometry, without which you cannot understand a single word of it, might be vindicated. So, let's assume that in nature is a law of gravitation between 2 point-like masses, m1 and m2, and is given by the equation 6. Let also the gravitational force, okay, the gravitational force be analogous to the two masses and dependent on the distance between them raised to an unknown exponent n. Exponent n. So, which means that the equation is of the gravity is the equation 6. By applying the principle of duality in the projective plane, where point interchanges its role with the straight line, we try to detect the gravitational field stemming from a linearly distributed mass in the linear segment A2 prime, with a density lambda kilograms per meter. So the impact of the gravitational field of this distributed mass at the point O, it's our question. The distributed mass, the linear segment, and the point O, they define a plane, axiom 3, upon which we operate. Now, the elemental intensity of the field of an elemental mass of length dx at point M, the intensity of the field at point O is given by equation 7, and this intensity is split in two components, according to equations 8 and 9. So, the total component of the total intensity of the gravitational field will be the after we synthesize the two components, after they have been calculated by integration. So,
the total horizontal component in the x-axis is given by equation 15, and because the integral is very simple. The problem of computation emerges when we try to compute the total vertical component. And by doing all these calculations, we arrive at equation 20. Equation 20. Thus, the calculation of the integral I that we see, it falls into an infinite series of calculations of similar integrals, with each time it's diminished, similar integrals with the exponent is diminishes by 2 each time. We don't finish the calculation because exponent n is unknown. So, to the calculation to be swiftly completed, only one capability exists. The factor before the integral of equation 20 to be 0. That means that exponent n is minus 2. So, the gravitational law comes with equation 6a. This conditionality, via which we arrived at the inverse square law, could be named briefest computation principle, BCP. After that, we calculate the two components, and we see that the total intensity of the gravitational field is in the bisector of the angle A prime or A2 prime. If we remember the kinematics of the material point, always the moving point was in the bisector of the conjugate rays. Thus, the kinematics of the material point in the projective space coincides with the dynamics resulting from the inverse law. That maybe is not a coincidence. So, let's examine the relativistic kinematics in projective space. Figure 6. Let's consider a material point that is moving in the projective straight line E and is now at position A, which is in the foot of the perpendicular, driven from the observer O to the straight line E. Its conjugate positions in the projective space are A prime and A2 prime. We see that A prime and A2 prime are tangential to the Apollonian circumference at the conjugate positions. 2. OA, the distance OA, that is R0, is the harmonic mean of the distances HO and MO. Harmonic mean, music. OA prime equals OA2 prime is the geometrical mean of the above distances. OS, S is the center of the Apollonian, is the arithmetic mean of the above distances. Thus, we conclude that those three mathematical means are elements of a geometric progression with first term R0 and ratio 1 over the Lorentz contraction factor. We notice also that radius R of the Apollonian is the geometrical mean of the distances AS and OS. That means that the straight line E is the polar line of point O with respect to the apology. Now let's go to examine the electrostatics to see that we have a similarity. Very fast. Let at point O, that is a charge, positive electric charge Q alone in space. Then an electric field following the inverse square law is introduced in space. Let's now assume that we bring a grounded metallic sphere, grounded here, metallic sphere with radius r in figure 7. We seek to calculate the electric potential outside in space. On the surface of the sphere, the electric potential is 0. To make this calculation, we perform the method that of the image or mirror charges. See, for example, Griffith's introduction to electrodynamics. According to this method, one negative mirror charge 2', but virtual, is introduced on the sphere, inside the sphere, and on the axis of symmetry SO, such as Q prime absolute value of Q prime over Q equals me Greek. Its position on the axis of symmetry is at point P at the unknown distance alpha from the center of the sphere. The problem can be solved once factor me and distance alpha are determined. And that is because then the electrostatic field that we seek will be the field of two known charges, Q and Q prime, at a known distance between them with the metallic sphere ignored. After the calculations, we get equations, the answers from equations 30, 32 and 33. From equation 33, it arises that the radius r of the sphere is the geometrical mean of the distances SP and SO, that point P coincides with the point A, point P in electrostatics, yes, coincides with point A with the kinematics. So, I skip there, and I go to the resume summary. This theory, this work, is based on two fundamental acceptances. One, the adoption of the natural philosophy of Werner Heisenberg and the school of Copenhagen, according to which a consistent natural description of the cosmos should not ignore the existence of the observer, who observes and measures the events, and two, the choice of projective space as the geometrical space of a natural description. This choice is validated following the fundamental separation of the perceptible space, which is objective, from the geometrical space, which exists only in our minds. All logically consistent geometries are accepted in mathematical science. The adoption of the geometrical space by a theory of physics is free. So, after this analysis, we arrive on the calculation of the inverse square law as a result of the principle of duality in geometrical space. This principle guides to the briefest computation principle, BCP, that emerges practically automatically, and this principle maybe is related with the principle of least action, with its well-known importance, consequence in classical or as well in quantum mechanics. Moreover, this work establishes that there is an internal relationship between the electrostatics and the relativistic kinematics of the material point in the projective space, which might offer future researches, alternative routes of approach for a final unification of the known dynamic fields. Thank you for your attention.
Thank you very much. We'll hold off on questions on this one and go on to the next speaker immediately. We'll go on to the next speaker now.
Oh, yes.